I wanted to take a couple minutes to talk to you about the proper notation for L'Hopital's rule, especially in light of what I've been studying and reading lately in AP scoring rubrics. There's a subtle distinction to be made between how we taught this concept earlier in the year and what I believe the AP readers are going to expect. So I took this problem from a recent free response question that we covered in class, where the graph of G was provided and f of x was defined for us as the integral from -8 to x of g of t dt. Notice the structure of this limit, which consists of a rational expression. And the more of these you start to work with, you can begin to sort of sniff out that when you have a rational expression of this style, typically L'Hopital's rule is going to enter into play. So I'm going to start off by using direct substitution, which is always a great way to start evaluating a limit, by substituting -4 everywhere I see x, which is going to give me this result right here. Of course, f of -4, by our definition above, is going to be the definite integral from -8 to -4 of g of t dt. And the denominator of our expression works out to be 16 plus -16. You can see where that's headed. Now let's look at that numerator for a minute. The definite integral from -8 to -4 is simply going to be the area between the curve G and the x-axis. And you'll notice that there are actually two areas of equal and opposite area. And for that reason, our numerator goes to 0, as does our denominator. Now we spoke earlier in the year about how it would be a mistake to say that this expression is equal to 0 over 0, because it's not really mathematically possible for a fraction to be equal to an indeterminate form. And so earlier in the year, we had coached you instead to use an arrow, something like this, to indicate that the limit is approaching 0 over 0. Everything that I knew prior to this school year told me that the AP graders were accepting that notation for L'Hopital's rule. But what I've learned more recently is that they're actually looking for students to have a slightly different approach, and that's what I want to share with you today. What I've learned is that readers would really like students to take the rational expression and break it into its component parts. That is, to take the limit as x approaches -4 of f of x, the numerator, separately from the limit as x approaches -4 of the denominator. Now I'm not going to go through the steps of the work as I did before, but it's safe to say that the limit of the numerator is equal to 0. And the limit of the denominator, as we showed before, is also equal to 0. Now it's okay to claim that those two individually are equal to 0 because you're just expressing the limit of the numerator and denominator separately. And it's certainly okay for a limit of a function to be equal to 0. The problem that the readers are going to have is when you say that the rational expression is equal to 0 over 0. So instead, what they suggest you do is treat those individual limits as their own separately, and then come back to the original limit and use L'Hopital's. You might recall that L'Hopital's rule says that the limit of an indeterminate form, when we get 0 over 0, can be rewritten as the limit as x approaches -4 of the derivative of the numerator divided by the derivative of the denominator. And remember, this is not the quotient rule. To make that step a little bit stronger, I would advise that you actually tell the grader what you're doing right above that expression. You'll see that in grading rubrics as well. Now that we've taken and applied L'Hopital's rule, it's time to go back to our method of direct substitution. So we can plug in here for x, -4, in the numerator and the denominator. Oops. Notice the denominator is no longer equal to 0. You can see that plain and simple. That's -4. And the numerator is f prime of -4, which requires us to understand the second fundamental theorem of calculus. Of course, if we do, then we understand that f prime of x is going to be equal to g of x. And so f prime of -4 is going to be equal to g of -4. Going back to the graph, g of -4 is the output value when x is equal to -4 on the graph of g. So that's 2 over -4, which is -1/2. I hope you found this helpful, and I hope you understand for the AP exam that they really would like you to see you evaluate each of these limits, numerator and denominator, separately before applying L'Hopital's rule.